Hey guys, good evening. Good evening. Everybody had a good weekend. Easter weekend. Spent time with the family and stuff. Hope everybody enjoyed their weekend. Of course, Monday was April Fools. There was a couple good April Fools jokes on Facebook. They were showing one of the nitrous companies had three solenoids on each fogger on an 8-cylinder manifold. We're calling it a 12,000 horsepower nitrous kit. It was pretty funny. Not as many as in the past. Hey Ryan, thanks for coming in tonight. But overall it was a good time. We got sorry, I'm trying to shut off the music. Okay. So, unfortunately, I did not make it to South Georgia Motorsports Park for the weekend for the grudge race up there that Slaughter Boys, our race team, put on. We could have had the engine back in time, but it had been last minute. And I really didn't think it was wise to rush to get the car together with no testing and go up and show our hand. So Smurf didn't get the engine in time, and we had some updates we were going to do, and we're not going to do them to make the race. And this way, we don't have to pull the engine in and out multiple times to get the updates done. We can do it all one shot, and I felt that was a much smarter, wiser decision. We really didn't have a major race or anything to do that. I think we had one grudge race that we just postponed. So it was just one of those things that better to not go than to go, and not be 100%. So, and Rihanna 2.0, the Regal, we never got the coilovers for the front of the car. They got lost in shipping or didn't get shipped or whatever. I don't know what the actual answer is to that. Nevertheless, I did get them today. But I could have had that car ready. We did a car swap in the shop, put Rihanna in the trailer, put Smurf in the shop. I finished up some small cleanup stuff, taillight wiring and stuff like that, and just kind of got some of the stuff that needed to be addressed, waiting for the engine. And then when we realized the engine wasn't getting here, we went ahead and swapped cars back. But by then, besides not having the coilovers, we had not enough wiring and stuff done to that. Mike says someone sent me a Texas Speed April Fool's ad for a Waffle House cam. It was pretty good. I did see that. You're right. Yep. Waffle House. It was something about faster than your food at 3 a.m. or something like that. I forget the little catchphrase. It was pretty good. I like that. That was cool. I don't know if anybody else saw any other ones that were interesting, but always fun to see the April Fool's jokes and stuff. I did see a couple people, some friends said, "Oh, we sold our house and we're getting an RV and going to travel the world and stuff like that." But I mean, those were kind of more inside joke than the ones that you see the companies putting out the ads. Those are the ones I always look forward to. Yeah, so we're getting. Oh, there you go. Open 24/7. So yeah, so yeah, so we didn't get up to South Georgia, so I spent the weekend at home and got work done here around the shop. And since I was messing around with the front suspension on Rihanna, I kind of got this idea. Maybe we'll do a chassis dynamics seminar, not seminar, me rattling off whatever I think I know. Uh, yeah, I'm trying to go back and put information in the titles of all the past live shows. This is being 39, so we've done a few now. But yeah, so that way, if somebody's looking for something, we had some really good break discussions, and I know I have to go back through and a bunch of Holly stuff like that. So I'm gonna go back through. I did like the last 10 or 12 of them because I remembered what we had talked about on those shows. So I need to go back to the beginning and start putting more context in the titles, so they can get some more people can check them out rather than just looking at Tuesday Night Live. Who knows what it's about? So I'm starting to do that. So anyway, like I was saying, I was messing around with some of the suspension on Rihanna 2.0, and I got thinking about it. I said that would probably be something we could do. We can spread this over probably 3 or 4 shows, and it's something that everybody should know this. You don't have to know it or be able to do it, but you should know some of this information just for your own knowledge. Like tonight, we're gonna start off with alignments. It'd be good to know the alignment information, so when you do go have your car aligned, whether it's a drag car, autocross, road race, or just a cruiser, so that you can, when you talk to the alignment tech, at least you guys can have a conversation on what you're expecting out of the alignment. Unless you go to a performance shop, most repair shops are going to put your information in your car in, and it's going to give you the factory specs, and that's what they're going to align it to. Typically, with most modern alignment machines have go, no go. So if the alignment is in the green, it's considered good and doesn't need to be adjusted. That's not really the case. That's just for the production shop that wants to push a lot of work out the shop and not really maybe do the correct job. If the alignment spec is 0 on camber and the window is -0.5 to +0.5, well, that's a big difference. You could have one tire -0.5 degree and the other side +0.5 degree, and that's nowhere near where it should be, but it's still within what they consider good. So good to know about this stuff, and that way you can have a talk with them, and you can tell them. I see Jim's on. Hey Jim, good having you in tonight. And then of course, if you're doing autocross or road course racing, performance driving, you probably want to adjust the alignment specs a little bit from what the original ones are. Sometimes you can buy a front end, like a suspension kit, and it'll give you some specs, but at that point you still, without knowing what they're really telling you, you're just saying, okay, well, here, align it to this, and not really knowing what the outcome going to be. Now, not saying that a manufacturer is not going to give you good specs, but it's always good to at least have somewhat of a knowledge of what those numbers mean. And for the person that wants to do their own work, an alignment is very easy to do. You can do it with a digital angle finder, or a level, and some string, and you can, and tape measures. You can do it pretty darn easy. And then of course it depends on how far you want to go with it. But that's the main thing of this. So what we're going to do is let's go ahead, and I kind of got this put together. I mean, you guys that are on the show all the time know I really try to put something together, but I really don't spend a whole lot of time on it because I'm busy in the shop all day. So, but I think this is going to be pretty good. So bear with me, and if you guys got questions as we go along, please put them in the comments, and I'll try to answer them as we go. And so here we go. So there's a typical race car chassis. Now this is probably like a K&N Pro Touring or something like that. It's not quite like a NASCAR, but definitely a circle track car. But this could be it could be a drag car. It could be anything, different design. But you know what I'm saying. You can build something like this for any kind of situation. There's another race car, stock car, and you can see this one has a stock frame under it. Here in the front of the vehicles, this is probably like some type of local Saturday night circle track car, something like that. So the whole reason we're going to do this show, let me raise this up for the guys that are on their phones and stuff. So vehicle dynamics. The whole reason we do vehicle dynamics is there is a lot of dimensional things going on in the suspension of a car, and we want the car to do the best, give us the best outcome for whatever sport we're trying to do, whether it's drag racing, road racing, autocross, drift, or just highway cruiser. You still want to have the best situation. You don't want to go through if it's any kind of, besides drag racing, you don't want to go into a corner getting on the interstate or going through a turn on a racetrack and the car not do what it's supposed to do. So that's why there is vehicle dynamics. A lot of things get involved in that. Hey John, glad you got in tonight. You have front roll center, rear roll center, and so these are the side-to-side geometry that the suspension does. And being that you have suspension, it's going to rotate. Those roll centers will rotate as the car pitches. So those are good, important things, because you want the front and rear to work together. You don't want the front to do one thing, the rear to do other thing, because now the car is either going to push or it's going to drive off the road or whatever. And to do a lot of this stuff, you have to figure out where the center of gravity is. So we're not going to get that deep into this tonight. But these are the things we're going to get more and more into as we go on through the live shows. So here's a picture of the front roll center. Now this is actually you can see the tires are tilted, so this is actually the roll center moving because the body is rolling. So what the front roll center is your angle of your control arms, and the contact patch of the tire goes to an instant center for the left and an instant center to the right, and the roll center is where those two instant centers interact. Now, typically on a front suspension, you want the roll center to be fairly low, probably 4 or 5 inches or lower to the ground. Certainly you don't want it below ground, because now the car is going to bind as it goes when it goes through the turns and stuff. This is a little drawing of front versus rear roll angle. So you got your center of gravity, which is where you're gonna, the center of the car. Center of gravity. Let me step back. I should have explained that first. Center of gravity would be basically if you put 2 pins at the height and the position of the center of gravity, you could pick the car up by those pins, and the car would be balanced. So you have a center of gravity front to back, and there's also, you can measure the center of gravity side to side. Most of the time we're talking more of side to side. So like in the middle of the door, the car was 50-50. You would say the center of gravity is around 16 inches. So you could put a pointer, if you could do that in the cartoon world, but you would be able to put a pin in that spot, and then the car would be totally balanced. You could move it around and it would always fall back to center. So your front roll angle and your rear roll angle are all about the roll center and the center of gravity with the centrifugal force of the car going through a turn. the better you can match those, the better the car turns. In any kind of racing where you are turning, anytime you can, let me say it again. So anytime you are in a vehicle that is turning, and you want to make it faster, it's very easy to make it faster in the straightaway. More horsepower, easy. But to make the car truly faster, and the guy that's going to win the race is the guy that makes it faster at the slowest part of the track, which is the center of the turn. If you can pick up 1 mile an hour in the center of the turn, it will usually be 2 or 3 mile an hour at the end of the straightaway. And that was all done with by working on the chassis. No engine changes needed. So that works for any kind of event where you're cornering. Drag racing, it's all about the starting line. Again, you can make more horsepower and make the car faster at the top end of the track. But if you can get the car off the starting line with the momentum and the roll angles of the car, there wouldn't be a roll angle. It's more of a pitch, anti-roll or regular, anti-squat or regular or positive squat. But the faster you can get it off the starting line, the faster the car is going to be at the other end of the track. And we've always said drag racing, if you can pick up a tenth in the 60 foot, it's 3/10 at the end of the quarter mile. Again, no changes to the engine. So it's a whole lot cheaper to dial the chassis in than it is to spend money trying to make more horsepower. So those are all the things that we go through with engine, with chassis dynamics. And here's another angle, another picture that shows slip angle. So again, this is important for Ackerman, bump steer, things like that. So anytime, again, you can make the car go through the slowest part of the track faster, you're going to pick up speed. And it's basically, for whatever it costs to get the chassis right, free, because engine horsepower costs a lot of money. So anytime you can do something, sometimes depending on your chassis, sometimes just by spending a couple hours adjusting things, it pays dividend. So that's what we're going to go over. We're going to break it up into different segments. Tonight we're going to do alignment, and we'll see. We'll go from there. Just change my screen here. So, we want to. So that's what we're going to do. We're going to go over the different parts of what's going on with vehicle dynamics and how you can check it, adjust it, and change it. And again, even if you're not going to physically do it yourself, just knowing about it is going to give you a heads up. You can be on track or on the street and say, my car has got a push, or my car doesn't turn right, or it's got a pull when I'm going down the road. Well, with the information I'm going to give you, you'll have a better understanding why it's doing it, and then be able to relay that to the person that's actually making the adjustments so you can fix it, whether it be yourself or if you go to a shop. So those are, that's what we're trying to, what we're going to go through with this segment. So change my screen again. Sorry about that. So here's a real inexpensive alignment tool, Fast Track, made by Specialty Products, SPC. I was trying to say SCP, but it's SPC. And they have a couple different attachments. This one actually grabs, with these little fingers, it grabs the inside of the wheel. They make a clip that you can change out to grab the outside of the rim, which is much better for a mag wheel or a painted or powder coated wheel. You don't want to put any pressure on the inside face of the wheel. But this tool locks onto the wheel, and then it gives you a bubble gauge down here to read camber and caster. So good little tool. They're not very expensive. Good thing about this, it doesn't matter what hub or wheel face or whatever you have, because it hooks to the rim. So everybody's got a rim, so it's easy to do. This is the old school method. This piece has a magnet, and so what they used to do back in the day is you'd take on your car with the grease cap, with the wheel bearings behind the little tin cap. You could take that cap off, and this tool would actually have a pointer that goes in the end of the spindle, and then the magnet grabs the iron of the rotor, and it does the same exact thing. The good thing about this type of tool is it's going off the hub and not the rim. So the other type tool, if you have a bent rim, you're going to get bad information because it's going off of the rim, where this went to the hub. Problem with this tool is not many cars have iron hubs anymore. You know, everybody with Bear and Willwood and other brake manufacturers like that, and the advent of aluminum hubs and everything like that. So that's where you know this tool doesn't work anymore. So now I've seen some guys use a rim clamp type mechanism and then stuck this to that. But I mean, at that point, you might as well just use the fast track tool. Chris says, I see, hey Chris, you're here tonight. Good. The perfect time. This is perfect timing before race weekend. Yes. So another thing you can do if you have a bunch of lasers, you can use lasers to do this. You can set them up perpendicular to the car and then use a tape measure to measure the rims and stuff. I like using a laser type method to make sure my steering wheel is straight, but we can get into that later. One thing you need to have to do a wheel alignment is a turntable. And what the turntables do is your front tire sits on this table, and that allows you to swing the tire for caster, to read the caster. And when you make toe adjustments, the wheels can float and not have a bind on the tires. If you don't have turntables, and most people don't, you can do a couple different things. Let me go back here. So you can take some floor tiles, linoleum floor tiles, and put some oil or some salt in between a couple layers of them and stack them, and you got an instant turntable. Let me go back to where I was. I got that out of sequence. So if you don't do any of that, then what you have to do is you have to roll the car back and forth to take the pressure off of the tire when you're reading it. Now here's a simple toe tool. It's a toe plate, and this particular one actually clamps to the rim, but the ones I have, I just lay against the tire, and you can go from side to side on the car, and you read your tape measure, and whatever the difference is, that's your toe. So if the front is 69 inches and the back is 68 and 7/8, you have a 1/8 inch toe out, or vice versa. If you're 68 and 65 and a half on the front and 65 and 5/8 in the back, now you're a 1/8 inch toed in. So it's a real easy tool. Again, anything that goes against the rim, though, you have to make sure you have straight rims, because that will change your readings. Another way of doing it is this is a scribe method. You actually jack the car up and use this tool, and you actually scribe a line in the tire, and then you put it back on the ground, and then you line up the pointer on both sides, and then you can, some of them you put on back, you lock it up, and you come to the front and you read the difference with a tape measure. Some of them have a dial here, and you just dial it and it tells you what it is. But this method will take any wheel run out or tire run out you have, and it will adjust for that because you've scribed a straight line on the wheel. Like I said, you jack it up, spin the tire, and scribe the tire, and now you've got a true straight line because now the tire is spinning off the spindle. So that's a better way of doing it, but if you have straight wheels, then the toe plates are fine. This is another style toe device. One thing you want to do, important for us because we're aligning the car for performance use, you want to put the driver's weight in the car. Now, very easily you can sit and have somebody that weighs close to the same if it's your car, or if you're doing it helping a friend with their car, you could set them in the car. But the problem is, by the time you make all your adjustments and you do all the things you're going to do, it could be 2 or 3 hours sometimes. So it's a whole lot easier to put weight in the car to simulate the driver. That way you don't have to worry about the person sweating to death and moving around while you're trying to read a bubble gauge and stuff like that. So it's always better to do that. What I usually do is I have lead plates I use, and I'll put 20 to 25 pounds down by the feet area, the footwell, and then I put the rest in the seat, and I try to stack it. I probably put like a third or half of what I have left over on the base of the seat, and the rest I try to stack up. So I'm trying to put the weight, simulate the driver in the car. The other thing I didn't get pictures of is you want to use a locking device to hold the brakes, because when you're doing a caster sweep, the wheel cannot rotate. If the wheel rotates, then you're going to get a fake caster reading, and I'll show you that in a little bit. But so they make rods with a flat plate, and you just push the pedal down as hard as you can, pull the plate up against the seat, and it wedges kind of like a hood, adjustable hood prop, and that locks the brakes on while you're doing your work. You want to take a level. I would use a little longer level than this, but you want to take a level and check the level of the ground that you're working on. If you've got a tenth of a degree of angle in the floor, then you have to adjust all your readings by that to get back to zero. So just kind of a thing. Now I've got a drive-on lift, and what I've done is I've adjusted my lift to where it's always in the level position when the cables are tight. So I've done that, and I know I don't have to keep doing it over and over again. But if you're going to do it on the floor, then you have to kind of do that. And then, of course, there's our inexpensive camber caster tables. And there's a picture of another type of device like the Fast Track. You can see how it grabs the rim, and then you've got this has actually got a level and a digital level on it. So easy to set up for camber. And you'll notice on the floor here, he's got some lines drawn out here. So he's got one line there that's parallel to the car, and then he's got this 2 angles here, and those are either going to be at 15 or 20 degrees, and that's used for your caster sweep. You want to rotate the tire in to a certain degree and then out to the same amount of degree so that you can get an accurate caster reading. So those are the tools you need. There's other equipment that you can use. You can change stuff around. You don't actually have to use those exact things. You can just be semi-creative. You're going to be looking for your camber, which is straight up and down. So you need to put a level, and it's hard to get a level. It's going to be exactly the right length for your wheel. Although you could cut a piece of tubing and then put a level, like a smart level or a digital protractor, stick that on there, and that'll give you your degrees. So 90 degrees would be 0 camber. So you can. There's other things you can do to make this work, but it's just a matter of reading the angles. So let's go back. I got the folders switched again. So now I'm gonna show you actually what the stuff is. So this is a camber. This is actually from like a tire shop or something. But the green, you can see the tire. This tire is straight up and down. So that is 0 camber, and that's going to give you the best tire wear. So if you're looking for ultimate tire wear, you want to get every ounce of tire tread life out of your tire, a 0 camber is going to be what you want. This one, you can see the tire is leaning out on the top, And these are like the suspension points. So this is showing the outside of the car. So when the top is out, that is a positive camber. And when the top of the tire is in, that's a negative camber. Now, we never want a positive camber unless you're adjusting it for racing. You can have a negative camber, which is good, especially for a street car. You can lay both sides in negative, and that's going to give you a little bit more cornering. I'll get to that in a second here. So here's another picture. It shows you the entire front end. This is like looking at the front of the car, and so negative camber, 0, and positive. And with the rectangles there, you can see more so what the meaning is there. Now this is why you would make these adjustments. So on a stock car, when you're only turning in one direction, obviously you can optimize your alignment because it's only doing one thing. It's turning left and going straight. Now, again, from our previous discussion, if you can make the car faster at the slowest part of the track, the straightaway doesn't matter. So in stock car racing, you give up your alignment for the straightaways and you align for the corners. So now, since you're only turning left, when you go into the corner and you turn left, obviously the car is going to pitch right. The left side of the car goes up, the right side of the car squats. So what you do then to get the best footprint at the center of the turn is you put positive camber in your left front tire, because now when the body rolls up, that tire is going to come back to 0. And then there's your neutral caster. Now here's lateral effects. Now here they're discussing this. So you can see on this wheel, it started out with a neutral camber, and now you've got the lateral effects going to the tire, and you see now we lost half the contact patch. If you put a negative camber in the front end, there you go. Now you get a full contact patch. And it would be vice versa for the other side. The driver's side, you would put positive camber to get that full contact patch. And the way we do that, obviously you can't put a gauge on it while the car's going around the track. So that's when tire temperature instrumentation comes into the factor. So many companies, Long Acres, Joe's, Intercomp, there's many companies out there that make tire temp sensors. And what it is a little gauge, and it gives you a probe with a little needle on the end of it. And what you do is you make a couple hot laps, you come in and get the car to a stop as fast as you can, and then read the inside, center, and outside of the tires. And those tire temps are going to tell you what the tire is doing. It's going to have some from straightaway. Most of your heat is going to come from turning. So when you can get that tire temperature balanced throughout the entire tire, say 110 across the board, now you know that your camber adjustments are correct. That's the whole idea of tire temps. Obviously, you want to keep your overall tire temp within a certain range to not overheat the tire and knock the compound out. But for alignment sources, that's what you'd use tire temp for. You'd come in and see that the insides are hot and the outside of the tire is cold. Well, then if it's on the left front, it needs more positive camber. If it's on the right front, it needs more negative camber. Now, on a road course and autocross, it gets a little tougher now, because now you don't have that one perfect turn. You're doing both. But the caveat there is, if the track is mainly right hand or mainly left hand, you can adjust your alignment to better suit that. So in a road course car, both wheels are going to be negative, but because you're turning left and right, and the inside tire, or the outside tire rather, of the turn is one that's going to be pushing the car, making the turn more so than the inside tire. So you kind of give up the inside tire and work on the outside tire. So if the track is predominantly right-hand turns, you would lay a little bit more negative camber in the left front tire than you would the right front tire. And then again, you look at your tire temps, and that's going to tell you where you need to make your adjustments at. So I didn't put that in the slideshow because we were talking about alignment, but it is a good tool while you're on track to figure out what's going on. And then there's toe. So we have toe in and toe out. All cars should have toe. So the whole reason for toe in and toe out is you want to load all your suspension parts so that you don't feel the free play in the tie rods and the steering joints, steering box, rack and pinion, whatever components you have for your front steering assembly. A lot of cars, especially in us with race cars, we use a lot of spherical bearings. Well, they have a certain amount of free play in them to make them rotate. So if you have your toe set at 0, you're going to feel all that deflection coming through the steering wheel. And it's going to feel like the car is floating or twitchy. Now, typically, a production car will have toe in. Most drivers prefer toe in for driver comfort because toe in kind of makes the front end a little bit more mellower on turn in. But if you want to go fast, you set the alignment for toe out. And the reason being is you can imagine when you turn the wheel, if you have toe in, when you turn the wheel, your inside wheel goes straight and the outside wheel is turning in. So now you're kind of getting a plowing effect. If you have toe out, now your outside tire is going to be pointing where the car is going, and the inside turn tire is going to be turned even farther. So it's going to even help pull the car around. The downside of that is you have to be aware that the car is going to have very fast turn in. And some people do not like that sensation. They feel like they're losing control when they turn into a corner. But if you can get over that or anticipate it and understand it, it's a much faster way of getting around the track. Toe in is great for straightaway. Toe out is much better for turning. It's just a faster, better way. You have, like I said, we have to have some amount of toe adjustment to keep the front suspension tight. So, toe in is good for driver comfort, and for straight line driving, it's awesome. It's always going to push the car back to center. But when you have toe out, now just the lightest deflection or lightest effort in the steering wheel makes the car react quickly. So it speeds up your reaction time for getting in and out of the corners. For autocross, toe out is not a must, but it's much better because you're coming out of a straightaway, right into a turn, coming out of a turn, going through a slalom. You really have no time to be slow on the steering wheel. You have to get after it because you're on a very short track. Most autocross tracks, you're within shorter than one minute on the track total time. So if you can pick up a couple hundredths here and there on every turn, it's gonna lower your lap times. So obviously toe out is the way you'd want to go. Now we can talk about caster. So camber is the squareness or the straight up and down of the tire looking from the front of the car. Caster is a little harder to understand. I always relate it to the forks on a bicycle or forks on a motorcycle. That is caster. So you have your contact patch on your tire and your steering head. Now on a fork, it would be where the handlebars are. So the farther that goes back, the more the tire wants to stay centered. The farther forward it goes, the wheel wants to follow. So think of this: if you're pushing your engine hoist or a roll around cart in the shop, or your wife's pushing, or you were pushing a grocery cart at the grocery store, they call it a caster, and those are positive casters. So the pivot point is ahead of the center line of the tire. So now the cart or the vehicle is driving the tire. The tire's not pushing the cart, but as you're moving the cart forward and you push it to the right, it automatically makes the tires turn to the right. There's no back to center. It's going to go wherever the weight is forcing it. Back in the day, when cars had bias ply tires, a lot of manufacturers would put positive caster on there because it would make the wheel lighter, especially when they didn't have power steering, so the consumer could drive the car. They didn't have to manhandle it. And the way the belted tires flexed, it made it much more comfortable for the person to drive. Now, as you go to negative, I said that backwards. Negative caster is what we'd have on a grocery cart. Positive caster is what we set in our cars now. So positive caster will, the more caster you put in the vehicle, the more the front end wants to go back center. It's always going to try to find center. So your caster, as in this picture, is a strut, but this could be kingpins, this could be upper and lower ball joints, it doesn't matter. Whatever pivot point you have on the steering, whether it be a kingpin, ball joints, or strut, that is the line for caster. That's how you measure caster. So if you're using a angle finder, you can put an angle finder on your strut or on the spindle if there's a flat machine surface on the spindle, and that would give you easy caster. But most things don't have that, so we have to use a tool to do that. And this is kingpin angle. We'll get into this in a future episode. You got a scrub radius, where here's the contact point of the tire, and your kingpin offset or ball joint offset, whatever that is, that would be a scrub angle where the tire is rotating around that pivot point. But we'll get more into that. That's got nothing to do with alignment. So now that we kind of understand what all these things are, I'm gonna go through step by step on a drag car alignment that I just did. Now this alignment, being a drag car, doesn't mean anything. It's all the same. No matter what the car is used for, it's all the same. Adjustments are different, methods are different, but the outcome is still all the same. So on any car that has a straight axle, we use a plumb bob and hang off the rear end housing. And then we can measure that to the chassis, and that will tell us whether the rear end is square in the car or not. So in a drag car, you have this chassis bar that's going side to side in the car, and it should be square. You'll have to take it if you didn't build it or you don't know, the first time out, you need to check that by Xing the car and measuring different parts on the car to try to make sure that this bar here is square in the car. But any well-built car will have a square point. Now, if you're in a production car, your pickup points for your ladder, your leaf spring mount or your lower control arm mount should be square, unless the car has been crashed. So again, you can X the car out with a tape measure to different holes and stuff. A production frame, there's a lot of holes you'll see in the frame where the manufacturer puts that in so it sits on a fixture when they're building the car. A lot of times those are square. So you'll have to, this will be something you'll have to figure out on your own car, but this is what you want to do. So on this car, I verified this was square, well-built car. So we can take that this surface area and go back to our plumb bob, and now what you would do, take this measurement, go to the opposite side of the car, and take the other measurement. They should be the same. If they're the same, then you'd want to go, I don't have a slide for this, but you'd want to go from the edge of the tire to the frame, from this towards the center of the car, and make sure that the rear end is centered that way between the frame rails also. If that's all those numbers are equal, the rear end is square, so the rear end is basically finished. Now, for a guy that's got independent suspension, you can use your camber caster tool on the back wheel, and you can read camber, and you can make those adjustments. You can find spots on the chassis where you can read, or you can just put toe plates on and read a toe, and you can see if the rear end tires are perpendicular to each other. On a straight axle, hopefully, if the rear end was built right, the camber is 0, and and there is no caster on a rear suspension. You do have some type of suspension like 4-bar or 3-bar or track arm or anything. We'll get into that stuff in the future. That's no bearing on your alignment. So that would square up. So you always want to check your back of the car first. And one thing I forgot to say, before you do any of this, check tire pressure. All the tire pressure needs to be the same. At least back tire is the same, front tire is the same. That way the way the tire's sitting on the ground, it all puts the center line heights all at the same. Just that's what you have to do to do all that. So you get all that squared out, and then you can take those measurements. So this car was square, so we didn't have to do anything to the rear end of the car. There's a whole picture of the overall, what we're doing. So then we put our tools on our whatever type of alignment tool you're going to use. I'm using my fast track bars, and you can see I've got my makeshift a table there. So that's how we're going to rotate the tire. Now you can see that the wheels are locked. I've got the brake on. I didn't show that, but the brake is on, and this piece here is 90 degrees front to back, so it's straight up and down. And we go to our tool, and you lock this device in, and this side is camber, and we're on 0. So we know that the tire is perpendicular, it's square, it's 90 degrees straight up and down. It's not cambered in, it's not cambered out. Being a drag car, that's what we want straight. We want the least amount of roll resistance on the front wheels. Obviously, for any other type of racing, you're going to put some negative camber in there to get what you're looking for. But you kind of, until you get tire temps, you got to just kind of make a ballpark assessment of where you want to go. But once you have that information, and then you can do tire temps, then you know which way to make the adjustments. So once you got your camber setting, then you go to caster. So we turn the tire in, so the front edge of the tire is facing out. And you see on this tool, as we were showing on that plate that the guy had drawn some lines, this has a caster sweep angle on the end of it, and it's 15 degrees. So we turn the tire till this piece is perpendicular to the side of the car. And then we zero our gauge in. And you can see now that the tool is leaning back. That's because there's caster and the tire is rotating around that caster angle. This is why it's important to have the brakes locked when you do this, because if the wheel rotates, and it'll gain caster readings, but it won't be realistic. So you have to have the brakes locked. So you have to have well-working brakes and something that's going to hold, because you're going to put the tool in there and hold the brakes, and it needs to hold it, while you're doing all this work. So, it needs to be a solid brake system to do this. So then we swing the tire the other way. Now you can see the top of the tool is leaning forward now, because again, the tire is pitch rotating around the ball joints. Oh, my wife's home. And then you read your gauge on this side, and you can see this car has 6 degrees of positive caster. Now, again, this is stuff that you gotta kind of get a feel for it. I've always had a rule of thumb, and it's kind of a saying in some of the racing circles I've been in, but the saying has always been, caster is faster, meaning the more positive caster you can put in the car, the faster the car is going to be. Now, for a street car, because most, especially here in Florida, our roads have a crown. They build a crown into the road to push rainwater off the road and not have standing water on the road. So, as I was saying earlier, caster is what makes the steering go back to center. So, if you have a pull in the car, your car is driving down the road and it wants to go left or right when you let go of the steering wheel, it's a caster issue, not a camber issue. Camber is more so tire wear. Caster is what's putting the load on the suspension and forcing the car to do what we want to do. Remember when we were talking about the negative caster, on a shopping cart. The shopping cart's pushing the wheels to make it turn. With positive caster, the wheels are making the car turn. So what you would do on a street car that sees very, very little track time, you want to put a half a degree more positive caster on the right-hand side than the left. And what that does is it gives the car a little incentive to push to the left. So it will drive up that crown in the road. It's got to go up the hill. So you put a little bit of cross caster in there, and that's what causes the car to stay straight down the road instead of falling off and running into the ditch because the road is angled down on the right-hand side. In stock car racing, we'll go back to stock car racing because that's a one-turn deal. You want to split the caster considerably. What I always set my rule of thumb is I want to go down the front straight about 2/3 of the way up the track, so not against the wall, but in about one lane out off the outside wall. And when I get to the turn, I want to take my hands off the steering wheel, and I want the car to turn the entire turn of the track and end up in the same spot on the backstretch. That is, to me, that is a perfect alignment because now the car is free in the middle of the turn. Again, we want to pick up speed at the slowest point of the track. So we're going to set our camber for the best contact patch, and we're going to set the caster to push the car around the track so the driver doesn't have to do effort. All the driver has to do is turn in, and the alignment is going to take care of the rest. So again, for road racing and autocross, now you're on a give up because you're doing left and right, so you have to give one up for the other. So again, if a track is leaning more one type of turn than the other, then you could split your caster that way. Typically, a lot of guys, and especially autocross, won't get into changing the alignment per track. So at that point, set the caster equal, and it's going to be really good on one turn and maybe not so much on the other turn. You'll have to definitely put more turn in effort. Again, that's why I like to put toe out, because now the turn in is going to be very fast and will compensate for the lack of cross caster. But that's what we're doing with caster, and that's why if anybody, Mike would know this, anybody who rides bikes, motorcycles, the more the fork angle, the more the wheel goes out the front of the bike, the more the bike wants to go straight. Whereas a road race bike or a cafe race or whatever they would call them, you can see the forks are a lot closer straight down. It's because they want a lot of reaction in turning. So it's just kind of so you can visualize your upper and lower ball joints, or if you've got a straight axle, your kingpin, or if you have a strut, your strut of your car. That's your caster, and this is what caster does. So the more caster, the more the car wants to return to straight after a turn. And then the cross caster helps it turn in one specific way more so than not. So if you've got a street car, hot rod, and it's pulling all the time to the left, you need to add a little bit of positive caster to push the car back to the right. And vice versa. If it's pulling right, you have to put a little bit more caster in. So the higher the caster is the way it's going to push the car the other direction. That makes sense. Hopefully it made sense to you guys. So once you get your camber and your caster adjustments made, and your adjustments are all going to be different depending on your car. Drag cars usually have rod ends that you have to adjust. Stock vehicles can either have eccentrics on the upper or lower arms, or they can have shims in the front on the upper or lower. You have to look at what your vehicle, what it entails to get that stuff, to make those adjustments. So then we go to toe. This is our last adjustment. Yeah, Mike says more rake, the straighter it likes to go. Yep. That's why you see all the big choppers and those guys are hands off the handlebar and riding down the highway, because the bike wants to go straight. It's built in to the chassis. So you got your camber and caster adjustments done. The last thing you do is your toe. So now on my fast tracks, hey Spider Garage, thanks for getting in. For the last thing you want to do is your toe adjustments. Now my fast track bars have little arms that come out, but I don't really like using them because it's pretty flexy and you can get a false reading. So I like using the toe plates, and it's just 2 1/4-inch aluminum plates with some holes drilled in it, and you just lay them up against the tire. Now you see I've got a pitch on the plate, and the reason is because the tire has a bulge at the bottom, so you don't want to push it against the tire because now the bulge is affecting the way that the plate sits. So I like to angle them out. Plus they sit real nice, that way you can work on the car and you don't have to worry about the plates falling off and stuff like that. So on this side, same exact plate, holes are in the same exact location. I put my tape measures in. I use 2 of the identical tape measures, and I use clamps to clip the tape measure into the hole to hold it, so it's a one-man operation. And very important is to check underneath the car and make sure your tape measure is not touching an oil pan, a suspension point, or anything, because you want, when you pull the tape measures tight, you want to get a true reading. If the back one is hitting the oil pan and the front one's not, well, obviously you're going to get a false toe reading. So you have to check what's underneath the car. The lower the car is, the lower the holes on your toe plates need to be. A lot of the toe plates you buy, like Longacre, and there's a handful of companies that make them, you'll see this, they have 2 or 3 slots in there, and that's the whole reason, is that way you can lower the tape measure to avoid obstructions under the car. Now, the thing is, wherever you put one tape measure, the other tape measure has to be in the same exact location to get a true reading. If it's in the bottom slot, it needs to be in the bottom slot. Top slot, top slot. So once we're done, we can look here and we can see our tape measure readings. Now, I was hoping this came out a little better, but it didn't. But the rear tape measure, let me see if I can blow this up here. So you can see this rear tape measure is reading 69.5, right to the edge. And the one in the front is 69 9/16. So that's showing that this car has a 1/16 toe out. That's where we have it set up at. So you get that done and your alignment is finished. Now you can go out and drive the car and see how it does for, if it's a production car, or if it's a cruiser or show car or whatever, you're mainly using it for highway. You can take it out, drive it on a couple different roads, because different roads are going to have different grades to them, and see how the car reacts. See if it has a pull, and stuff like that. Track cars, now we go to the track and test, use our tire temp gauge, read tire temps, and then start making notations in your logbook, and then go back and make the proper adjustments to get the alignment to where it's the best it can be. So that's going to be basis for the first show tonight. So this is all about alignment, and then we'll slowly, each week we're going to work through a different section. So next week I think we're going to go ahead and finish up with the front suspension. We'll do things that we didn't talk about today. Bump steer. Bump steer is another important thing to check. when you're building your car and when you are doing your initial alignment, because you want to make sure that you don't have bumps there. And what that is when the car goes over a bump, the steering geometry stays the same. So let's just say a normal car with an upper and lower A-arm and a tie rod. So all those have a pivot point on the frame. So you have a lower control arm pivot mount where the lower control arm mounts to the frame, and the outer pivot point, which is the lower ball joint. And in the upper, you have the same thing. You have a bar in the top where it's a crossbar, or it goes into the frame into a pivot point, and you got the ball joint on the opposite side. And then you have an inner tie rod and an outer tie rod. So you have three components there, and they're all going to pitch they're all going to have an angle, rotation. So if the tie rod is in a different angle orientation, it's going to go out or in. It's going to change the toe when the suspension is moving, whether it drops or goes up. So that's where you want to make sure you have zero or as close to zero bump steer as possible. Ackerman helps the car turn, and we'll get into that stuff next week, and then some roll center stuff. John says a lot of great information. Thanks, George. Thank you guys for coming on. For the guys that came in late, you'll have to watch on the replay and watch all the different portions of the alignment segment if you're interested in figuring out wheel alignment. But this is kind of like the beginning of vehicle dynamics. You have to know what your alignment is doing before you can go on track and figure out all the other things, lateral loads, yaw, slip. All those things are important, but if your alignment's no good, those are never going to be right. So you have to start out with an alignment on the car, have all that properly set. Like I said, on a track car, use tire temp gauges. You need to. Let me start off with that again. I'm sorry. So you have to come up with an alignment spec that you think is going to be good for the car, and then you go out and test, and you read your tire temps, and then you finite that alignment by balancing your tire temps from inside, center, and outside on your treads. Once you have the alignment squared away, now you could start working on the other aspects of the vehicle dynamics. So that's what we're gonna slowly work through this. Let me preface that I am not an engineer. I did stay at a Holiday Inn once. No, I'm just joking. But this is, close to 40 years of being in this business, and I've been doing race car setup probably after maybe the first 5 years of turning wrenches. So early on in my career, I learned the wheel alignment, and then friends had road race cars and drag cars, and I figured out and read and learned, and we put that information into what we were doing, and then through trial and error, we came up with where we're at. A lot of times at this point in my life, I can look at the car, kind of figure out where the weights are before I even put it on scales or anything. And I can pretty much tell you where your instant centers are going to be, what your alignment should be. So that that's as John says, experience trumps engineering degrees, and I believe that too. It's really awesome to know the book or the computer engineering side of dynamics, but the proof is in the stopwatch or the time slip. That's where everything. That's the end result. So if you can make that better, you're in the right direction. You're doing the right thing. And I've seen where sometimes engineering leads you one way, but another way is actually faster. So it's really cool. I really love chassis setup. It's a fun part of the business. I hope you guys that may be thinking about, or you have your own car, hot rod or race car or what have you, you can for minimal amount of money, you can start doing your own wheel alignments, and you can start looking at how things wear and stuff like that, and you can play around with camber and caster and see how it reacts in the car and how it drives, and from there you can build your own experience. Yeah, Mike says it tends to dislike engineers. Yeah, working on OEM cars at the dealership, that will definitely leave a bad taste with engineers, because they really muck those cars up. Race cars, luckily, the engineering is a little bit more freehand. A lot of this stuff is, unfortunately, monkey see, monkey do. One guy builds a chassis, and the next guy mimics his chassis and builds it. Some guys will think outside the box and start making changes. So, but yeah, so this is the basic thing, alignment, and then we're going to get into the front suspension geometry. We'll get into rear suspension, which will be really interesting. A rear suspension is going to give you a lot of information on traction. If you can't put the power to the ground, you're spinning your tires and you're not going anywhere. So I think you guys will find it interesting. We'll get some information with cars on the scales, and we'll be able to put that into all this, and hopefully it'll all make sense when we're all done. So John says, I have a hobby providing engines rolling lots of fun. Yes, sorry. I don't know why, but on Facebook or on YouTube, they've got a heart right on the chat. So I always don't see the last word. So I'm sorry. It's not that I can't read it. It's just I can't see the word. So sorry about that. But anyway, hope you guys enjoyed tonight's show. I'm looking forward to the next, I don't know, it may take 3 or 4, 5 shows. I don't know, till we get through this. I try to want to break it down so that it's understandable. I didn't see a lot of questions tonight, so I'm assuming that this portion was pretty straightforward. I'm glad to see that. So it shows you guys have a general idea of what's going on with the wheel alignment. So proving damn autocorrect. Yeah, that's a whole nother, providing autocorrect. That's right. That's a whole nother thing is a darn autocorrect. I hate that. I can't tell you how many times I've sent somebody a message and it's not what I said. Chris says, question pushing 8AN Fragola fitting on the line. What is happening? Sorry, I got to put my glasses on. Question, putting an 8AN Fragola fitting on the line. What is happening in the line is spinning the last 3 or 4 rotations before tight. Is that acceptable? Yes. What's happening is the fitting is not sliding inside the hose. I showed putting lubricant on the fitting before you stick it in. Well, sometimes the lubricant gets rubbed off as the fitting is going on, and it starts grabbing, and that will spin it. As long as the hose isn't backing out while it's spinning, then it's no good. But if the hose stays in the same position, but it's spinning, that is okay. Mike says, radials blow my mind after years of wrinkle wall side tires. Yes. And when we get to rear suspension, you're going to be, you're going to freak out about if you know how wrinkle wall slicks and how we've always set race cars up for slicks with squat. We've always wanted the car to pitch rotate to the back tires, put as much load on the tire as we can to plant the tire to accelerate the vehicle. Radials are completely different. So, but that's for another show. But tune in. We'll get to that. I hope you guys enjoyed what we got tonight. I guess we'll go ahead and wrap it up at this point, and look forward to seeing everybody on the show next week. If you had some questions and weren't able to get them out, write them down and put them on the show next week. We can always go back over anything that needs to be gone over. like I said, next week we'll probably do more front suspension, but it'll be more in the engineering design and how it works and why it works. And then we'll move on from there. So appreciate it. Thanks everybody for logging in. Thanks for the guys that put stuff up on the board. And think about your vehicle and what it's doing, and think of questions for future episodes, and we'll work our way through this deal. So thanks again, and everybody have a good evening. John, have a good evening, and we'll see you guys all next week. See ya.